Hello friends, welcome back to our this new video. This is video number 12 based on topic solutions. So in the previous video we have studied the second colligative property, that is what, the boiling point elevation. So in that case we have seen that the boiling point of a solution increases when non-volatile, non-electrolyte solute is added into a solvent. And we have also seen the lowering of vapor pressure is one of the important evidence that proves how the boiling point elevation occurs. So in that case we have seen that the vapor pressure of a liquid when becomes equal to its atmospheric pressure, at that temperature liquid boils. So that is according to the definition of boiling point. And as the vapor pressure of solution is found to be lower than that of the vapor pressure of pure solvent, so therefore that is the more heat is required to make the pressure of solution, vapor pressure of solution equal to 1 atmospheric pressure compared to the heat required for the pure solvent. And that's why the more heat or at high temperature the vapor pressure of solution becomes equal to the 1 atmosphere, and that's why the more temperature or more heat is required for the solution, that's why the boiling point elevates or increases. So in this video we are going to learn the very important relationship between, that is the molar mass of a solute and the boiling point elevation. So that is what, how to determine the molar mass of solute from boiling point elevation. So that is the aspect of our study. So see, we have already studied, we know that is delta TB is equal to KB into M, where delta TB elevation in boiling point, KB molar elevation constant, and small m is the molality. So in the previous video we have already studied this relationship. So see, suppose we prepare a solution by dissolving W2 grams of solute in W1 grams of solvent. So such type of simple consideration is there. What is that? Suppose we prepare a solution by dissolving W2 grams of solute in W1 grams of solvent. So therefore number of moles of solute are given by the simple formula W2 upon M2. We know. Okay. We know molality is equal to what? Small m, moles of solute upon mass of solvent in kg. That is the number of moles of solute present in mass of 1 kg solvent. So that is what? The molality. So say, so we can write now like this, W2 upon M2, where M2 is the molar mass of solute, W1 upon 1000 gram. So if the weights are taken in grams, so instead of kg, so we can convert it into 1000 gram like this. So mass of solvent in kg, therefore we will get this formula, or W2 into 1000 upon M2 into W1. Or see here, by substituting this value of M in equation number 1, this मोलॅलिटीची किंमत आपण ठेवली, सो डेल्टा टीबी इज इक्वल टू केबी इंटू W2 इंटू 1000 upon m2 into w1. So this is the simple relationship between the molar mass and the boiling point elevation, or how to obtain the derivation, or how to determine the molar mass of a solute from the boiling point elevation. So I will revise in brief, try to understand. So we have to take the use of this. We know delta Tb is equal to Kb into m. Then what is our consideration? Suppose we prepare a solution by dissolving W2 grams of solute in W1 grams of solvent, which is having the molar mass m2. Solute having the molar mass m2. So number of moles of solute are given like this, W2 upon m2. And we know molarity is equal to what? Moles of solute present, that is mass of solvent in kg. Is it right? Number of moles of solute per kg of solvent. So we can write like this. Moles of solute W2 upon m2, mass of solvent in kg, W1 upon 1000 grams. So when it is taken in grams, so we can write here 1000. पहा मग हे वर जाईल इथे 1000 आणि अशा पद्धतीने आपल्याला फॉर्म्युला मिळेल. सो दॅट इज व्हॉट द मोलॅरिटी. So by substituting this value of molarity in above equation here, we will get what? Delta Tb is equal to Kb into W2 into 1000 upon m2 into W1. So this is very important because its application is that we can easily find out or determine the molar mass of a specific solute by knowing the boiling point elevation or from the boiling points of pure solvent and solution. So see here, we will see here one numerical. The normal boiling point of ethyl acetate is 77.06 degrees centigrade. A solution of 50 gram of a non-volatile solute in 150 gram of ethyl acetate boils at 84.27 degrees centigrade. Evaluate the molar mass of solute if Kb for ethyl acetate is 2.77 degrees centigrade kg per mole. So read the numerical carefully. What is that? The normal boiling point of ethyl acetate is given 77.06 degrees centigrade. A solution of 50 gram of a non-volatile solute in 150 gram of ethyl acetate boils at 84.27 degrees centigrade. We have to evaluate, means calculate the molar mass of solute if Kb for ethyl acetate is also given. Now see here, the boiling point and the Kb molar elevation constant is given in degree centigrade instead of Kelvin. So doesn't matter whether the boiling points and this elevation in boiling point delta Tb and Kb may be in degree centigrade or Kelvin, doesn't matter because these are the differences. So both these terms are calculated by comparing or differentiating, or that is nothing but the difference between the two quantities, and that's why it doesn't matter. So just we have to use it in degree centigrade or in Kelvin. So we will keep it as it is here. So now rearrange this formula. So we have to determine m2 molar mass. पहा m2 आपण अपोजिट साइडला घेऊन गेलो तर डेल्टा Tb m2 ची जागा घेईल आणि आपल्याला हा फॉर्म्युला मिळेल. m2 is equal to 1000 Kb into W2 upon delta Tb into W1. Okay. आता पहा what is given? The normal boiling point of ethyl acetate. That is what? See here. Ethyl acetate. Normal boiling point of ethyl acetate is given. That is the boiling point of pure solvent. Delta 0B. This one 77.06. Then say ethyl acetate boils at. So when non-volatile solute is added, so this is nothing but the boiling point of solution 84.27 degrees centigrade. So in this way, from this we can calculate easily delta Tb, and this is the difference. पहा फक्त काळजी एवढी घ्यायची की दोन्ही डिग्री सेंटीग्रेड मध्ये असतील तर चालतं, कारण हा दोन्हीतला फरकच आहे डेल्टा Tb. केल्विन मध्ये कन्वर्ट करण्याची गरज नाही, परंतु दोन्हीचे युनिट डेल्टा डिग्री सेंटीग्रेड मध्ये असावेत किंवा केल्विन मध्ये असावेत. तर अशा पद्धतीने त्याच पद्धतीने Kb दिलेला आहे, हा सुद्धा डिग्री सेंटीग्रेड मध्ये आहे. केल्विन मध्ये असेल तरी चालतं किंवा डिग्री सेंटीग्रेडमध्ये. आता हे डिग्री सेंटीग्रेडमध्ये आहे म्हणून आपण त्याला सुद्धा काय करणार आहोत केबीला पहा जशाच तसं ठेवलेलं आहे आपण. देन परत काय दिले पहा 50 ग्राम्स ऑफ नॉन व्होलाटाईल सॉल्यूट दॅट इज नथिंग बट द W2 पहा W2 50 ग्राम है 150 ग्राम ऑफ इथिल ॲसिटेट दॅट इज W1 वेट ऑफ सॉल्वंट ओके. आणि अशा पद्धतीनं मग आपल्याला काय करायचं डेल्टा टी बी कॅल्क्युलेट करून घेता येतो आणि जस्ट वी हॅव टू पुट द व्हॅल्यूज. सर्वांच्या किमती जर आपण अशा पद्धतीनं ठेवल्या पहा 1000 इंटू हा फॉर्म्युला आहे आपल्याकडे KB 2.77 इंटू 50 7.21 इंटू 150 कॅन्सल केलं तर हे लॉगच्या सहाय्याने आपल्याला इझिली सॉल्व्ह करता येतं. पहा लॉग ऑफ दिस प्लस लॉग ऑफ दिस प्लस लॉग ऑफ दिस मायनस लॉग ऑफ दिस प्लस लॉग ऑफ दिस आणि हे जे आहे सबस्ट्रॅक्शन आणि लॉगच्या सहाय्याने आपण सोडवलं तर 128 ग्राम्स पर मोल येतं. सो दॅट इज नथिंग बट द मोलार मास M2 ऑफ द सोल्यूट. सोल्यूटचं ते मोलार मास आहे. हे कॅल्क्युलेशन तुम्हाला इथे पाहता येतील मी सॉल्व्ह करून दिलेले आहेत पहा 1000 कॅरेक्टरिस्टिक त्याची 3.00 इथं ठेवलं एकाखाली एक घेतलं मी आपल्याला बेरीज करायला सोपं जावं 2.77 लॉग 0 येईल 27चा 7 मध्ये पाहता येईल. पुढं पहा याची कॅरेक्टरिस्टिक 0 येईल 50चा 0 मध्ये पाहिला याची बेरीज केली तर एवढी येते तिकडे पहा परत लॉग 7.21 कॅरेक्टरिस्टिक 0 येईल आपण 7.2चा पाहिला 1 मध्ये तर अशा पद्धतीने लॉग मिळेल आपल्याला प्लस लॉग ऑफ 15 कॅरेक्टरिस्टिक येईल 1 त्याचा पाहिला याची बेरीज केली याच्यामधनं हे वजा केलं 2.1075 तर लॉगच्या सहाय्याने करत आहोत म्हणून याचा अँटीलॉग पाहावा लागेल तो आपल्याला 128 आन्सर मिळतं. तर अशा पद्धतीनं इझिली मोलार मास आपल्याला कॅल्क्युलेट करता येतं. सो दिस इज अगेन व्हेरी इम्पॉर्टंट दॅट इज ऑल्सो द ॲप्लिकेशन ऑफ एलिव्हेशन इन बॉइलिंग पॉईंट. पहा तर अशा पद्धतीनं जर आपल्याला या फॉर्म्युल्याचा यूज करावा लागू शकतो आणि याच्यामध्ये ज्या गोष्टी दिलेल्या आहेत त्याच्यापासून एखादी अननोन गोष्ट कुठलीही आपल्याला फाइंड आउट करता आली पाहिजे कॅल्क्युलेट करता आली पाहिजे. सो दॅट इज ऑल अबाउट दी second qualitative property boiling point elevation. Okay, so in next video we will learn regarding to the third property that is depression in freezing point. Okay, we stop here. Thank you. Don't forget to like and subscribe.